Hello everyone, and welcome to Island Technologies presentation on management and monitoring of DrayTek devices. My name is Java, and I'm a technical sales specialist here at DrayTek Australia and New Zealand. This is part 2 in a series of webinars where we talk about the various available options to manage and monitor your DrayTek devices and discuss the tools available for troubleshooting any network issues you may encounter. Today, we'll continue looking at DrayTek routers management options. And in the upcoming webinars, we will be deep diving into Wi-Fi management options and software-based central management platforms. Today, we'll continue on from part 1, where we looked at the dashboard and system maintenance menu options in DrayTek routers. In this session, we'll focus more on the diagnostic options that are available. And as always, please stay tuned at the end because me and my team will be online for 5 minutes to answer any questions. So, the diagnostic functions are mainly used to monitor the router and troubleshoot any abnormal issues that you may encounter. Here's a look at the options available under the Diagnostics menu in the Vigor 2865 router. Most of these functions will be available in other DrayOS routers as well. The examples I'll be using today are from the Vigor 2865 and Vigor 2927 series devices. Let's go over each of these options in more detail. We'll start off with the first menu option, which is Dialout Triggering. This page shows the packet header that is transmitted when a WAN connection, such as a PPPoE connection, is initiated. Both hex format and the decoded format is displayed. It's mainly for information purposes only. Next menu option is Routing Table. This page displays the IPv4 and IPv6 routes. The routing table is built up from direct connections, static route entries, and dynamic routing by using the RIP version 2 protocol. Policy-based routing will also add entries to the routing table, as well as inter-VLAN routing if enabled. There are a number of components in the routing table. The 3 components shown here are the destination IP plus subnet mask, gateway, and interface. The first column shows type of route where C is connected, that is, the WAN interface is directly connected to this IP address. S is equal to static, where the route entry is manually entered under the LAN static route setup menu. And next up is R, which is RIP, where the route is learned using RIP routing protocol. Asterisk is the default route, that is the default path if no other routes exist to a destination. Tilde symbol is private. The second column is the destination IP address and its subnet mask. The third column is the gateway IP address. And the last column shows the interface being used, which can be a WAN port, USB WAN, or VPN tunnel. The very first entry in the routing table is the default route, which is shown as 0.0.0.0/0.0.0.0. When a workstation needs to send data to a destination host or network, the router is usually involved in making that communication possible. However, if the router cannot find the destination network in its routing table, then the address will be unreachable. In this case, a default route is configured in the router to send all data packets for unknown destination networks to the interface corresponding to the default route setting. In the example shown here, all packets destined for unknown networks are sent to WAN 1, which in our example is 168.95.98.254. More information on routing is available in a webinar we ran previously. You can see the link on your screen. I've included that in the video description below as well. Next, the Arp Cache Table displays the IP address and MAC address of devices connected to the router. When devices connect to the router, their IP address are stored in the cache memory known as an Arp table. Arp, or Address Resolution Protocol, is the method for finding a host's MAC address when only its IP address is known. This is used to maintain a correlation between each MAC address and its corresponding IP address, and is constantly refreshed by the router to reflect changes in the network. The Arp cache can be used when troubleshooting network issues such as IP address conflicts, as it'll show the MAC address of the device using that IP, and also to verify that the devices are in the correct LAN. Next item is IPv6 neighbor table. This displays the mapping between Ethernet hardware address, that is the MAC address, and IPv6 addresses. This information is helpful in diagnosing network problems such as IPv6 address conflicts. The DHCP table displays IP addresses for devices connected to the router. You can use the information on this page to troubleshoot IP address conflicts and other network issues. Incidentally, DHCP is configured under the LAN General Setup menu in the router. Network Address Translation, or NAT, is a mechanism where one or more private IP address can share a single public IP address. This table displays the latest 128 NAT entries. It shows the source and destination IP address and ports used, as well as the WAN interface. The router sets up a pseudo port in the NAT session table, which is a temporary port used for NAT to keep track of the sessions. This table can be used to troubleshoot port redirection or open port issues when port forwarding is not working as expected. Now this diagram shows how NAT is used. It allows several LAN users to access the internet using one WAN IP address. So any local users communicating with the internet will show the same public IP address, which in our example is 123.24.25.1. So far, so good, but what happens if we want specific traffic to be directed to a specific device on the LAN? How will the router know which device to send that traffic to? To get around this issue, we use what is known as ports. For each WAN IP address, there are 65,536 ports for TCP and the same for UDP. You may use any external port as long as it isn't already in use by another device on the network, bearing in mind that some ports are reserved for special purposes. For example, HTTP uses port 80, HTTPS uses port 443, and RDP uses 3389. So down the bottom there, we've decided we want any external packets going to our public IP address on port 85 to be directed to the PC with the private LAN IP address 192.168.1.10, while packets on port 86 we want to go to 192.168.1.11, packets on port 87 to 192.168.1.12, and any packets on port 88, we want to go to 192.168.1.13. This information will be displayed in the NAT session table when the connections are active. Next, we have the DNS Cache Table. DrayTek router can function as a DNS server, which allows LAN clients to look up DNS info by sending requests to the router. This DNS information is temporarily cached in the router and can be viewed on this page. Before we can see any entries in the DNS cache table, we need to configure the LAN DNS settings in the router. This diagram illustrates that local private IP addresses can be mapped to a domain name to be used on the local network. Next is ping diagnosis, which is a handy tool to test connectivity to a host on the internet. You can enter the host IP address or its DNS name, and the router will send ping packets to the remote host. It also measures the round trip time to give you an indication of the speed and quality of the connection. We can use it to check whether a break in connection occurs and also verify whether DNS resolution is working on the router. Let me explain this with an example. Let's assume that you can ping the ISP gateway, but can't ping a device behind the gateway. You'll know straight away that the problem is on the ISP side. Ping can also be used to test if a VPN tunnel is working by pinging a host on the remote network over the VPN tunnel. Ping measures response time as well as the amount of packet loss, which indicates the condition of the internet connection. A poor quality connection may have a large number of dropped packets, resulting in timeout results. In the example shown here, we pinged google.com and got a reply from the IP address with a response time of 10 milliseconds with no packet loss. It can also be used to ping LAN devices to check if they're working. Dataflow Monitor can be used to check the real-time bandwidth usage for devices on the LAN. The number of sessions being used at a given time is also displayed. This feature can be used to troubleshoot high bandwidth usage by a LAN client. It also displays the current and peak data flow for each WAN connection. This page is periodically refreshed according to the time interval selected, which can range from 10 seconds up to 1800 seconds, which is 30 minutes. So it cannot be used for long-term recording or monitoring of traffic flow through the router. The Dataflow Monitor can also be used to verify that settings configured in bandwidth management and bandwidth and session limits are working as expected. There's an option to block a particular device for troubleshooting. Devices will be blocked for 5 minutes by clicking on the link. If required, you can unblock manually before 5 minutes. This can also be used to temporarily free up some bandwidth if the WAN connection becomes congested. The traffic graph is a handy feature that displays the transmitted and received traffic for each WAN connection over a period of time. Please note that it doesn't show traffic for an individual device, but total traffic to the internet. It can be used to check for unusual activity in the router, such as high traffic loads after hours when you expect to see minimal traffic flow. When setting up the traffic graph, there are two options that can be selected. The first is the reporting period, which can be daily, weekly, or hourly at 3, 6, or 12 hours. The other selection is to monitor traffic load for a particular WAN connection. You should note that the data is not stored permanently in the router. For long-term recording of traffic flow, it is recommended to use the older Smart Monitor software or Vigor ACS 2 or 3. These software applications will store the data on the server. The next diagnostic menu item is VPN Graph. This is available in higher-end routers such as the Vigor 2865, which support more than 2 VPN tunnels. It displays the VPN syslog settings for host to LAN and LAN to LAN connections. Also, the VPN traffic over a period of time can be displayed in graphical format. Traceroute is a handy network diagnostic tool used to track in real time the pathway taken by data packets to a destination network. In addition to reporting the IP addresses of all the routers it pinged in between, it will also record the time taken for each hop to the packet makes during its route to the destination. So if a remote site is unreachable, Traceroute can be used to check if the cause is due to a break in the data path. For the remote host, you can use either the domain name or the host's IP address. Traceroute can also be used to check that routing settings are configured correctly. For example, if we set up route policies for traffic to be sent over certain WAN connections, as shown in this diagram, we can use Traceroute to check that the correct WAN connection is being used. In the example shown here, we want traffic to 8.8.8.8 to go over WAN 2 and traffic to 8.8.4.4 to go over the LTE connection. We can easily set up load balance route policies to do this. The load balance route policies will look something like the settings shown here. Index 1 in the load balance route policy is configured to send traffic to 8.8.8.8 through WAN 2, while Index 2 is configured to send traffic to 8.8.4.4 through the LTE connection. Once it's set up, we can run Traceroute to these two destinations. We should see the path being over the correct WAN. As configured in our route policy, we can see here that traffic to 8.8.8.8 is going out over WAN 2. Next on the list of diagnostic tools is Syslog Explorer. It offers a quick way to review and download the router syslog. Some low-end routers may not have this option. Syslogs are used to diagnose various issues. For example, a VPN connection is not being established or a firewall rule is not working as expected. The syslogs collected can be filtered by selecting one of the syslog types. Selecting all will display all the logs. If you only want to see the VPN logs, then you can just select the VPN filter. A maximum of 1000 lines can be displayed here. For more extensive syslogs captured over a long period, it is recommended to use the USB syslog, which will save the log files to an attached USB flash drive. The web syslog can be downloaded using the export function, so it can be sent to DrayTek support for analysis. The IPv6 TSPC status page could help to diagnose issues with IPv6 connections that utilize TSP that is Tunnel Setup Protocol. If TSPC is configured properly, the router will display the details as shown in this example here. This will be displayed when the router is connected to the tunnel broker successfully. Next, we have the DSL status diagnostic page. This is often used to troubleshoot VDSL issues. It shows the firmware modem code, upstream and downstream speeds, signal-to-noise ratio, attenuation and errors such as CRC, as well as many other error conditions. The information on this page can be sent to DrayTek support along with syslogs to help find the cause of the VDSL connection issue. Sometimes the cause can be noisy phone lines or the modem cores used not being compatible with the NBN connection. Usually, using an incompatible modem code results in unstable VDSL connection or sometimes failure to connect. Some parameters such as SNR margin can be tweaked by using the telnet commands. Next, we have the high availability status page. It displays status of all routers that belong to the same DARP, that is DrayTek Address Resolution Protocol group. This diagram shows high availability using hot standby mode, where the routers share a common WAN source. The primary router is online, and should it fail, the secondary router will take over and become the primary device, using the same WAN to connect to the internet. The secondary router is always synchronized to the primary. The table displayed on the page shows the status of the routers that are part of the high availability group. Clicking on Status, Router Name, IPv4 or Details links will show further information for that device as shown here. In the Authentication Diagnostics page, we can see which users have been authenticated by Radius or 802.1x. We have two tabs on this page. The first being Authentication User List, which displays details of users who have been authenticated. The other tab is the Authentication Information Log, which, true to its name, displays the complete authentication log information. The DOS flood table is a handy feature to readily identify potentially malicious network traffic. For this to work, it needs to have the firewall feature defense setup to be configured and thresholds to be set. Once it is set up, then any DOS attacks detected will be reported in the DOS flood table. This page shows IP addresses that are currently engaging in DOS flood as detected by the DOS flooding defense mechanism. It provides useful information to network engineers, example MIS engineers, to diagnose the network environment to identify potentially malicious network traffic and entities. Identified IP addresses and the destination ports used in SYN, UDP, and ICMP flood attacks will be shown on the respective tab pages. IP addresses that are suspected to be attacking the network can be blocked by clicking the block button on the SYN flood, UDP flood, and ICMP flood tab pages. In the DOS flood table, we have 3 tabs for each type of DOS attack. It shows the IP addresses that are currently engaging in DOS flood. This provides useful information to network engineers to diagnose the network environment, to identify potentially malicious network traffic and entities, the IP addresses, and the destination ports used is shown on the respective tab pages. If an event is triggered, then a red X is displayed next to that IP address in the table. The network admin can click the block button to block this IP address. In the example shown here, a SYN flood event is detected for the IP address 192.168.1.11 and a red X is displayed. Here we see the other two tables that are available. The UDP flood table lists the incoming IP addresses and ports used for the UDP flood attack. The other is the ICMP flood table. It shows the source and destination IP addresses. For both of these tables, the network administrator can block these IP addresses by simply clicking on the block button on the page. The last diagnostic menu option we look at is Route Policy Diagnosis. This is linked to the load balance route policy settings in the router. It's a handy diagnostic feature to verify that routing policies are working as expected or troubleshoot routing issues within the router. There are two modes that can be used. These are Analyze using a single packet or analyze multiple packets using an input file. For those who are not familiar with load balance route policy, it is used to send traffic out through a WAN, VPN, or LAN based on configured criteria. For example, in the diagram shown here, we want LAN 2 traffic to use WAN 2 and all other traffic to use WAN 1. And use an route policy diagnosis can actually verify this. Let me explain this with an example where we want traffic going to 8.8.8.8 to use WAN 2 and traffic going to 8.8.4.4 to use the LTE WAN, which is WAN 3. In order to keep things simple, I'll be using the same network topology I used earlier. Here we have the load balance route policy settings for the first rule, where traffic to 8.8.8.8 will use WAN 2. And this is the other rule where traffic to 8.8.4.4 will use the LTE WAN. In the route policy diagnosis, we select Analyze a single packet. We need to enter the destination IP address, which is 8.8.8.8, then click the Analyze button. The results will be displayed both in graphical format and in the table at the bottom highlighted in green. It shows that the data sent matches route policy rule number 1. Okay, this brings us to the end of our presentation today. To summarize, we continued from where we left off from our previous webinar and looked at the diagnostic options available in DrayTek routers. These tools help us to monitor router functions as well as aid in troubleshooting network issues with features like ping, traceroute, syslog, DSL status, and so on. Usually, these diagnostic tools will be your first point of call when you encounter a network issue before going to more complex troubleshooting tasks. Okay, that's it for me, but please stay tuned. Me and my technical team will be answering questions in the live chat on the right of your screen for the next 5 minutes. For more information about DrayTek products, please check out our website at www.draytek.com.au or send us an email to sales@draytek.com.au or simply give us a call on 0298 388 99. Don't forget to like and subscribe below. And if you'd like a notification of new premiere videos we're about to launch, or anytime we put up a new video, please give the bell a click too. Thank you very much for joining in today's session. Please stay masked and stay safe. Until we meet again, goodbye.